So just like within the real numbers, we have identities. So if you recall, a simple identity is 3 times 1. Any number times 1 is going to give you the same number back. That's multiplicative identity. And 3 plus 0 is going to give you the same number back. That's additive identity. So we do have a matrix, an identity matrix, so that if I take any matrix and I multiply it, I'm just going to call it capital I here for identity. Any matrix times its identity is going to give you back the same matrix. So for example, if I have a matrix, just let's say a simple 2 by 2 matrix, and I multiply it by its identity matrix, and what the identity matrix looks like is it's all ones along the principal diagonal and all zeros everywhere else. So notice that there are all ones here and everything else is 0. So if I multiply that out, I am going to get the same matrix back. Okay. If I have a 3 by 3 matrix, that principal diagonal is going to, or excuse me, identity matrix is going to look like this with all ones along the principal diagonal and all zeros everywhere else. So here I've got all ones and everything else is 0. So if I multiply some matrix, we'll call it B, times that identity matrix, I'm assuming B is a 3 by 3 matrix, I am going to get that same matrix out. So now let's talk about an inverse. So just like with real number operations, there exists a number so that like with multiplication, if I take the number 3 and I multiply it by its inverse, I get 1 out, right? So 3 times a third is 1. Or I can use exponents. I can say 3 to the negative 1 power times 3 to the first power equals the number 1, right? Because it's 3 to the 0 power, which is 1. So these are the second component to this, or actually they are inverses of each other, right? These two numbers are inverses of each other because they give you the number 1 out. So likewise with matrices, if I have a matrix, I'm just going to call it matrix A, and I multiply it by its inverse matrix, and the notation is to the negative 1 power. So matrix A times its inverse is going to give me the number 1 out, or more precisely, the identity matrix. So we can assume that for any matrix, there exists an inverse to that matrix. So for now, I am just going to call this one, oops, let me go back to this. I'm just going to call this A, B, C, and D. And if I multiply it by its inverse, then I will get the identity matrix out. Or, in other words, any number times its inverse gives you the number 1 out. So any number times its inverse gives you 1, or any matrix times its inverse gives you the identity. So all I'm going to do now is just some simple matrix multiplication. So if you recall, 2 times A plus 3B equals 1. And if you recall, first row times first column gives you this first position up here. So just remember multiplication. And then we're going to have 2C plus 3D equals 0. And then 1A plus 2B equals 0. And 1C plus 2D equals 1. And now, using either RRRef or Gauss-Jordan, I can put these into a matrix to solve, right? All I have right here is I have a system. I have a system of 2 equations and 2 variables, and over here I have another system of 2 equations and 2 variables with an equal sign in between. So I can set this up as an augmented matrix, remember? And that would be 2, 3, 1 and 1, 2, 0. And using either RRRef on your calculator, or if you had to by hand, it would be the Gauss-Jordan elimination. So either one of those, I can solve for those 2 variables. And if I came over here, I could do the same thing. Oops. So this would be 2, 3, 0 and 1, 2, 1. And again, RRRef or Gauss-Jordan. And if I did that all, I would end up with over here, oops, yeah, A equals 2 and B equals negative 1. And over here, I would end up with C equals negative 3. Oops, negative 3, yeah. And D equals 2. In other words, the matrix, because remember up here I gave it a matrix, A, B, C, and D. So I would have the matrix 2, negative 1, negative 3, and 2. So in other words, this original matrix, we'll call it A, so matrix A times its inverse, this is its inverse matrix, will give you out the identity. And you could try that on your calculator. Enter this as a matrix, enter this as a matrix, and multiply the two of them, and you'll get the identity matrix.